Hi. When you come to this page, you will immediately realize that this is talking about springs. Yes, we're going to be talking about springs. But this is going to be a spring lab, which you will be doing. This is just like any other inquiry lab you will do in class, and you will be writing a lab report based on that. The only difference, you will be using an online environment in which all these apparatus are available and the errors have been routed in the simulation. You can meet me during my office hours to ask me any questions you have regarding the lab. One of the office hours is on April 27th at 4 p.m. to 5:30 p.m. on Monday. At this point, maybe you may want to watch also this video in a phone so that because you're going to be parallelly working on a document and also working on the simulation, watching this on the phone can make it a little easier, but it's not a mandatory requirement. You can still toggle between them. Now, what do we do first in the lab? We explore and observe. So what are we going to explore and observe, and what do we have? Here it is. Go to this particular link. Now this link is also provided in their Google Classroom. You can just go there, and in the same assignment where this video is there, and also the same assignment where you'll be uploading your lab report. And then once you go there, click on intro and you will land up into this place. This is where you're going to explore and observe. You're going to explore what the simulation does, change different things, what you can change here, and find out what is happening there. How can you change a spring? How can you change the applied force? How can you change different things, and what are the reactions of that? Try it out. Now, once you do that, as usual, what we do is build a hypothesis. Stop here at this point of time, and then go to your document, title the document, write an introduction, and build a hypothesis. That is your lab report. It will be building on the way as you go. Now identify the variables and constants. You may want to come back to the simulation, play around a little bit, be clear about what variables you will be measuring to verify the hypothesis. Again, you may want to come back again to the simulation to explain how you can verify the hypothesis. And can your hypothesis be tested for different springs you simulate? Oh, can you simulate different springs? There's a way to do that, and you will figure it out in the simulation. Write a procedure. Now again, now that you stop again, this will take some time. So stop this video, go look at the simulation, and keep on writing the document where what is the procedure you'll use in the simulation in order to collect data. But please make sure that you at least collect data for 3 different types of springs, or I'd say 3 different characteristics the springs can show. Like there's a way to change the nature of the spring. So you know that you'll figure it out when you do the simulation. Design your data table. You know the variables, you know the constants, enter all of them, and then design and you collect the data. Now, once you collect the data, what do you do normally? Is that you analyze the data. The purpose, as usual, is to see whether your hypothesis is supported or not. You can just do it with the data table, but it's always good to do with a graphical visualization of your data and interpreting its features. Now, how does this help? It helps you build a mathematical model. That's the next stage you will do, is that you build a mathematical model between the variables and see what is the relationship between them, and how does that help you interpret whether your hypothesis is supported or not. And the simulation also provides something called a spring constant to be changed. How does your what part of your mathematical model relate to that spring constant? For some of you, the way you have done the visualization, it may be the same, a number directly coming there, or something related to the numbers coming there in your model. Make a conclusion. Now, on all labs, after you make a conclusion, you have taken your model and extended it beyond the particular situation and then try to come up with something. And here is the place where you will think about this. Energy stored in a system is the work done on a system by an external agent or force. Now, what did you learn about computing work done using a force versus displacement graph? Both of these things we have done in the class. We talked about this in the class. Now you're going to apply that to this situation. How can you use it here and arrive at a relationship for the potential energy stored in a spring when it is extended or compressed? Do all springs look alike? Search the internet for different types of springs. Identify where they are used in real life. By now, if you look at the background of this particular video, you should know that there are so many types of springs and so many places they are used. Identify some devices in your house that use springs and explain that as an application in your report. Now, let's go a little bit beyond. Does a rubber band or hair band or a bungee also behave like a spring? What are the differences? Oh, how can we test it? Think about it and let us discuss that in the synchronous session. You may not make this part of the lab report, but you may want to talk about this in the synchronous session. What is the difference between these and a human muscle?